For this reason, in order to solve following problems, the inverse should be found, which will be the original function. So example 2 says the inverse of the linear function. They give us the inverse. They want to know the original. We do it exactly the same way that we were doing this yesterday. We switch x and y. So remember, that's just a fancy way of saying y. So we've got x is equal to 1 over 9 y minus 7 over 9. So steps remain the same. Switch x and y, solve for y. So our first step was to add or subtract. So we add 7 over 9 to both sides. Then we multiply or divide. We've got a 1/9. If it's a fraction, we multiply by its reciprocal. The reciprocal of 1/9 is 9. 9 over 1. 1/9 times 9 is 1. That's why we do that. We distribute the 9 on the other side. We get 9x plus 7. If you don't believe me, type in your calculator. 9 times 7 over 9 is 7. Y is by itself. So that means f of x, the original function, is 9x plus 7. And this is the inverse. They gave us the inverse. We found the inverse of the inverse, which is the original function. So exact same thing we were doing yesterday. It just looks a little different because they give you the inverse first and are asking for the original. But the process is exactly the same. So let me remind you of confirming these. Okay, if you type in in this case, the original function that they gave us, 1 over 9 x minus 7 over 9, that was the inverse, and we type in 9x plus 7, our original. Remember that when you type that in with y equals x on the graph, their intersection points, the line y equals x should go through that point as well, and they reflect over that line y equals x. They're mirror images across that line. So that's a way to check that. Okay?